Welcome to Caveman Coding again. This is another stream, and in this stream we have a lot to do. Um, so we have these things to do today. So let me just point it into VS Code, and so yeah, so we have the to do, which will the first thing we'll do is this and learn about the makefile, learn about the GDB and TCP server client using SHM and poll system call and combine exec and TCP server daemons and selecting poll, get sock name, get sock adder info, all of these things we need to do. So yeah, let's start off with I'm gonna do um yeah, yesterday's problem that we did not quite solve it yesterday. So let's just do that first. It'll be quite quick. So yesterday's problem was the first we left this problem. So we will try to complete it today, which is this thing where you'll implement a iterative TCP server that uses select system call as part of this question. The client program must accept the IP address and port of the server and an input file name from the command line. You will read data from the input file and write that data to the server. Assume it is a text file, then sleep for 1 second before reading the next data and writing it to the server. When the end of the file is encountered, close the socket and exit out of the client. The server program accesses the port number and output file name as the command line arguments. It reads the data sent by the clients and writes the data received into the output file. In the end, the output file is a concatenation of all input files of all the clients. Assume that a maximum of 5 clients are connected simultaneously to the server at any point of time. So let's just do the question one. Let's just rename this to server. So let's try to first implement a server. All of the includes just do str.h lib.h. I think we'll change the current to do standby text to select again. Right, so that is the thing. And st am I audible though? Yes, I'm audible. Okay, so include sys slash types.h, hashtag include sys slash socket.h, hashtag include unis.h, include arpa plus inet.h. Let me just increase the font size. String.h obviously. Also let's include the netdb.h. Okay. I think that's cool. Or let's just also include the sys select system call, which is sys select.h. Now let's just do the int main argc car pointer argv in array. Yep, okay, cool. Now let's just do if argc is not equal to the file name, the port, and the output file, right? Port number and output file as command and arguments, so it will be 3. And usage server IP knows it is port and output file. Will be 0. And just to exit of 1. After that you can do port checking, but I'm not gonna do port checking. I'll just do this. This is better. Server port server port, you can just do port. I think that's enough. And then char output file is gonna agree to. I'm gonna change this to exam so that I do not have help from the from this from VS Code. So listen FD. After that you can just do struct sock add in client add and serve add. So, and after doing that, of course, you just check this. If listen FD is less than 0, then let's do p error listen FD. And exit. And then just do serve add dot syn add. It should obviously listen to all of the ports. So I mean all of the addresses, and serve add dot syn port is equal to h2ns port. Cool. And what else is there? Serve add dot family will be equal to if inet address family, and then do bind. So if bind, if bind basically this call these listen FD on listen FD. The struct sock add pointer serve add, and then probably size of serve add. Now if this is less than 0, then you just do p error bind, and then obviously close the listen FD, and then exit 1. So yep, that's cool. No, I don't think. Wait a second. Yep, that's cool. And then do listen. Listen on a max number of clients. Just do if. Sorry, if listen on the listen FD max clients. If it turns out to be 0, then just do p error. Listen, then exit 1. Before doing that, just close this. Oh, damn it. Before doing that, close this and copy this and define max clients. Damn it. Fine.
Yes, everything is just fine.
Shut up. Define max clients to be 5. That's cool. And after that, do a while loop which keeps on listening for incoming clients. Now the incoming clients, uh, for doing that you can just do int fd int n ready to keep track of how many events are ready in the select system call that we'll use in the while loop. You can just do and then you can define fd sets, r set and all set. All set is used for keeping the track of all of the sockets, and r set used just to, because selector as a selector is just used as a copy. And then fd set you have, and what else do you need? Let's see. So you can just copy r set is equal to all set. Before doing that, you have to initialize all set. So all set, basically you have to initialize that, so you can just do fd0 before doing that you can actually include the statement fcntl dot h fd0 pointed to all set, and fd before doing that fd set listen fd. You copy the listen fd to monitor it for monitoring into the all set. Cool. That's cool. Also you can just do, okay, that's cool. Nice. Now you can just do n ready. You can use that on select system call. The first argument will be, oh, what is the first argument though? What is the first argument? Number of file descriptors. Oh yeah, the max fd basically. So this is just the max fd, which you can just do max fd int, and you can do max fd is equal to listen fd before going into the loop. this will be max fd plus 1. It will be set to that, and fd set, basically you can just do rset to monitor rset, and 0 0 0. Timer is also 0. That's cool. And after that, if just do if n ready is less than 0, then basically the select system call is 1 second, the return statements, return. Yeah, -1 if an error occurred. So you just do p error of select, and do exit. That's cool. And max fd, okay, that's cool and all. Let me just clean it up. It's cool. Also, to keep track of the client's active connections, let's just create an array, which is clients, which has max clients as the size, right? And then you have to initialize this for int I is equal to 0 to I less than max clients I plus plus. You just set all of these things to -1. Yeah, cool, that's cool. And then what do you do? After doing this, if n ready is less than 0, pr select and exit 1, and then just do, obviously, what do you do after getting something for these are set? You just check if listen fd is available, is ready. So that is done by if fd is set on the listen fd. So on the listen fd, from the rset, then it means that it is ready. Accept new connection, so you need to accept the new connection. To accept it, you need to create another socket, basically. You can just do int confd. So do the confd, put it into the accept system call, which takes in listen fd, and actually takes in the client's address. So it'll actually do struct sock add pointer. You just cast this to the pointer of client, and before doing that, you need to create a uh, damn it. Or this would be a sock length actually. So after that, you can just do plain length. You put the size of operator on client, and then you can just pass. You can pass in per client length. That's cool. Now if count of d is less than 0, then accept this field. You just continue to the next iteration of the while loop actually. So after getting count of d, you're accepting the new connection. Now you can just set, if you can just set this conf t to the r set basically, or I mean all set. So you just set the conf t to the all set for monitoring. After doing that, you can just set the client's array to an active connection. So you just check if client of I is less than 0, which means that it's not active. Then you just set that thing to conf and then break out of this for loop. Cool. And after doing that, you just check for max fd also. If max fd is greater, sorry, if con fd is greater than max fd, then set max fd to con fd, and then uh, and then you just do if minus minus n ready, is decrement the n ready, and check if it is less than or equal to 0. Then you just do continue, because continue, which means that do not go further into the code, and just continue with the next iteration of the loop, of the while loop basically. That means again call select, because the end ready as the ready descriptors are done, uh, and you need more, so just continue to the next iteration, which means that call while loop again. Cool. Now if actually if it is not listen empty, then obviously then it is confd. It is one of the confd, one of the confds, which means handle the client, basically handle client. So that means before that, no, I think that's it. So if it's not listen fd, then it is one of the confds. That means just for loop you can just uh, max clients I plus plus. If you can just set this, you can just check if the clients array you can implement it as sockfd is equal to, you can do int sockfd here, or just put it somewhere there. And sockfd, put it into, retrieve from client side. If the sockfd is less than 0, that means it is not the confd, it is null basically, and it's not an active connection, which means that you need to break out of the, or you need to continue. So you need to continue to the next thing until you get it right, because sockfd, you can just do break also. You need to continue, okay, right? You need to continue until you get the sockfd which is greater than 0. Okay, that's cool. Now the sockfd is actually the confd, so you just call a read on it basically, and you can also check if it is ready first of all. So if you should check if it is ready, so you need to do for all of the clients, so that's cool. Now if this particular thing sockfd is ready, which means that if fd is set on the, if the sockfd is part of the R set, which means it is ready, and we can handle the client, then handle the client, which means that you can do int n for the number of bytes actually. So int n, so you can use that thing, n is equal to read from the sock ft from this sock ft into a buffer, which we will define it somewhere here. We'll define that here. Buffer max line, you can just do max line as 1024, so you can just do 1024. This you can do max line. Amazing. You can put it into buffer, and size of buffer is, you can just do max line, so 1024 bytes. Yeah, now you can just do if n is less than or equal to 0, then there are two conditions here. You just check if n is less than 0, then obviously it is p error. The read has failed, basically. Read has failed. And then obviously just close the sockfd, and obviously you can just do exit one, or you can just do break, and then after calling it you can just do exit afterwards, but okay. But if it is equal to 0, then you just print out that the client has close connection. Close the connection. Line character. And you can do fprintf per se. I mean, str. Before that, after listening, you can just print out that the the client is listening. I mean, sorry, the server is listening. Server is listening on port on port. Let's just do %d. You can just do port. Yep. Oh, it's a char. Sorry. And yeah. Listening on port is this. That's cool. It should be ampersand though. Where's the thing that I wrote just now? Should be ampersand. Alright, so and then I'm just gonna come back for I'm just gonna come back within 5 minutes. Let's. I'm sorry, the mic was off. Okay. The open. So after getting it, after reading, you can do open and write it into the output file basically. Open is just the path basically. The output path. Where is it? You find it somewhere. Output file. So do that. Flags. Well, write only. Open for reading and writing also you can do. Let's do that. And then file permissions, nothing. Cool. This will return a file descriptor int out of t. Cool. And then you can just probably you can use this to write, basically call it into the write function. Write the out of the the out of the from the buffer. How many bytes? N. Attempt to read those many things, and if it returns less than 0, then just do query error write failed, and then just do exit 1. Is it exit 1 or yeah, exit 1. If out of D on this less than 0, just do p error open system call, just do exit. Cool. After that, again, yeah, the if statement, just do if and ready less than equal to 0, then you've done everything, and just do break. Out of the for loop. That basically, yeah, do as many times as many clients are ready basically, and then just break. out of the for loop. Out of the for loop, yeah, out of the for loop, you just can close listen FD. Before that, if it is less than 0, then if it is, if it is equal to 0, the client has closed the connection, and you can just clear this out. You can just clear the sock FT from the all set, right? Cool. And then yeah, pretty much that's it. And then let's do exit 0. Yep, it should be out of the for loop, while loop actually. It should be out of the while loop. True. Yeah, I think that's it. Let's compile the server code. I'm sorry, we need to do Jan 14th, and then cdq1, and then we can just server dot c minus o server. There's a warning there, but the argument is int pointer. It should be our int pointer 48. It's not be this actually, it's just is this. Yep, okay, that's it. Cool. So it has compiled, and in similar way we can just do the client also. Let's just do the client now. We can just copy all these things into here. The main function can be copied, but instead of this, instead of the number of arguments, actually, tell you what, the arguments should be, what are the arguments? Must accept the IP address, the port of the server, and an input file. So it should be 4 IP address, port, also the input file. Also the input file, right? Okay. And then you can just car input file. Just do arg v 0123 0123, so 3. You can just do define the sock FD. You can define the struct sock addr in serve addr, and then the port also can be done. It's okay. The port can be A to I. Argui 1 0 1 2. So it should be 2 actually. The port is 2. Okay. The IP address also IP address can be done actually by doing that, but let's just first create the socket actually. Secret a finite a oh my god, a finite sock stream obviously, and then 0, and just do let's say sock fd less than 0, then let's do p error socket, and then exit 1 obviously, and then pretty much what else. We did not do this actually, we need to actually do this. Yeah, void pointer memset void b into c size, right? This should actually be here too. Cool. And then do serve add dot syn family, a finite serve add dot syn port can be h2ns port, and for the IP address you can do inet p to n. Let's open a man page. A socket, just I mean sorry, the address family, source which will be argui 0 1, so will be 1, and the destination. So let's just do the destination do, I mean just the IP address. Let's do the IP address. Oh my god. Or just do the address. Car pointer to the address. Mm. Actually, you need to do add. The address length will be, actually, the size of this will be, let me show that. Where should, yeah, it'll be inet 6 address length. So it's inet 6 address length. That's cool. And then just because there is a pointer, right? That's a pointer. I think you just do that. Maybe it's just a little confusing, so let's just change the name here. Server address. Cool, that is cool. Server address. Now, what is the return value of this though? Can it return? This is the return value. My god, my hand. So return value dog. Okay then. So there is the, I don't know, if this thing is less than 0, just do p error inet p1 and then exit 1. Cool. It returns null, so cool. Alright, so after that you got that. So after that you can just do server dot syn, or you can just put it directly actually. So you can just put it serve add dot syn add and pointer. Yeah, you can just do that directly. That's cool. Oh my god. After that, after doing the socket, you need to do connect on the sockfd. Damn it, sockfd. So there should be struct socket pointer casted this way. It should be serve add size of serve add. Cool. Now if this whole thing becomes 0, then just do p error connect and then do exit 1. So after connecting that, you can now send it. Send is just to open Open const char pointer, which is the input file name pointer, and all the flags. So the flags of this will be o read, right? So o read only, and don't create it. Yep, that's cool. And it will return an int. So int, damn it, return an int. So if int nfd is equal to 0, and if you just do that, basically just do this. Yeah, just do this. Just to, if this is less than 0, then just do. Okay. Let's do this. Actually, this is better. It's a little confusion there. Oh my god. Exit one. And then, actually, I just remember that output file is a concatenation of all input files of all the clients. So you need to open it, open this output file, and write it in an append mode actually. You need to not write it there, right? I think you can do append, right? Yep, append. You can use a mutex also, but is there any mutex? Should be synchronous. Cool. I think that is needed. And now you can do read. From the NFT, and the buffer, obviously buffer. Let's say hardcode. I'll just do this thing. Just press hardcode. It doesn't matter. Buffer, and then let's just do hard coding thing, and also do intern and is equal to this up if n is less than 0. You read from the file, but how do you read it though? You read the slash n file also. So it needs to read until the end of the file, which means that while while this expression is not equal to 0 in the file, do it. Let's just read it. It should read until the end of the file. And it'll automatically read until the end of the file though. 0 is written, okay. I don't think this is required though. You can just do if n is less than 0, just do p error, exit 1. But if it is not less than 0, if you can just do else if n is equal to 0, it means the end of the file. Stop it. Okay, you can just do while 1, keep on reading. I do this a blunder though. Okay, I don't think this is even required because it will read until the end of the file. The maximum will be less than, the file size will be less than 1024 obviously. If it's not, then that's the edge case, but yep. And now just write into the socket. That is cool. What's the other though? Yep. After writing, what's the condition though? Like, okay, this is true. This is true. Okay. 1 second. Um, so the thing is, we need to, after comparing both of these things, um, let's compare it here again. So after doing that, EC2 server listening at 8081, it's cool, and the output file will be output.txt. It's not read yet, created it. It's not even printing that it is listening though. What is wrong here? Client, the loopback address, the port, the input.txt file was up. The output file is not being created, but what is the problem here? Well, it needs to print this, but I don't know why it's not printing it. Let's modify this thing. You can just do debug basically. You can just do if defined debug hashtag define debug this fprintf to standard error debug percentage s percentage d percentage d line function file, and also the m \n, close it, then do this, and then the line basically the function the file, do that, and if not defined, which is else, hashtag define debug to non-operational basically, and then end if. Cool. Now we can do debug. Let's just do debug. How do you use this? Oh, this v argument should be there. So the variable arguments should be there, and where is debug though? You can just do printf basically a debug. You can do the printf. You can do the printf socket creation done. Same thing you can use this to bind done. This and also you can do this and done. Probably it's just the issue with the port, I think. Port is 012. Port is first only output. Let's just compile it. Sorry. Let's compare it again. Okay, it works. And now let's just compile it with this flag 3 years generated. Hmm. Line function file via arguments is this only. What is wrong here? Does it need to have a variable argument though? But the variable argument thing is only to not have a trait, like to be variable. Let's just not go through this route first. Let's just try another route. You can just print it out actually. You can just print it out. I mean, it's not big of a deal, but let's do that later. One second. Well, yeah, so it is listening on about that. I don't know why he was not listening then. Did it create the? Did not create it. So it was listening on port 1 8001. Uh, if that is the case, let's just do printf accept complete. Client has closed the connection. Oh, which means that it has done, but it did not open. Okay, that is interesting. Hi from client is there. Hi from client is there, but the client is only something wrong with the client only. IP address, port, input file. Is it even opening it? Let's just print out. Reading done. And then print out writing done. I have not closed it. Writing done. After doing this, actually we need to close the sockfd and return. Exit 0. So let's just compile it again. Task compiled. Just compiled. Server is listening. Import that. Accept complete. So it has accepted it, and the reading is not done. Oh, damn it! Damn it! That's a silly mistake. Sorry. Client. Right. Server. Start the server. Start the client. Damn, close the connection has completed. Is there is an output txt. Amazing. Amazing. Amazing, bro. So finally, we have done it. We have done it. Amazing. So let's do with multiple clients though. So let's do with multiple clients. The same input file will be good only, or we can just do input to .txt for client 2, even client 1, even client 2. Save both of these things. Now compare it again. Start the server. Input 1, input 2, close the connection, writing done. Is appending, that's cool. It is appending, but I'm trying to. But why is it after serving one client only it is closing it? N is 0. We are closing this. Why? So it's not exit though. It should continue. Right? It should continue. It should continue or break? It should continue. Right? It should continue. So let's just do that again. Okay. Okay. No such file, and it has read bad file descriptor. It's closed. Okay. Thing is, it should be input 1. But the thing is, I did not check if the read it should exit, but why is it like bad file descriptor there? Because I've not sent it anyway. Why is there a bad file descriptor on the server side? First compile, and then start. Saying read bad file descriptor for the second thing. What is output? Hi. It's only hi from client 2. No, no, let's see what's happening here. Okay. After that, hi from client 1, hi from client 2. Input 1, input 2 is appending. Okay. But the thing is, it's saying that read bad file descriptor in server. In server, where is sock FT? After closing it, after closing it, should it be continue? Or break? Should it be break? Okay, it should be break actually, because what is the thing though? It should be break. It should not be continue for the next thing. So if it is break, then it should come out of the for loop, which means that it has served it. Oh, exactly. So it has served. It has completely served it. Oh, nice, nice, nice. Got it, got it. Because when you do continue, it's still the same sock FD, and it'll be 0 because you closed it. That's why it's bad file descriptor. I think so. And when I do is Control C, is done. But it is writing like that. So you need to open it. Ah, well, okay. But there was another point actually in the question. Another point that was in the question, that here in this question, It's saying that you read data from the phone, write the data to the server, assuming it is text file, then sleep for 1 second before reading the next data and writing it to the server. Close the socket and exit out of the client. So to sleep for 1 second before doing that, which means that until the end of the file, it just reads until the end of the file, right? So like, what are the input file? I'm just doing this. Has two things. Like what does this say? What does this happen? What does have wait what happens here? What happens to the output then? Yeah, I mean hi from client one and also bye from client one is coming. So why is there why is there why is there a sleep then? Because read will because read will return when end of file is read as 0 is return. Sleep for 1 second. Second. I am. It is working though, but I'm not too sure about this thing. Then sleep for 1 second before reading the next handwriting server. So they have kind of less time. So let's just give it to ChatGPT and do it. So so um, apparently it just means that this client um, and this means that you can just do this. Yeah, if it, as long as it's greater than 0, uh, you just do write, and then after write you do sleep after writing it, and then after that continue doing that. Yeah, it's pretty simple. Cool. And you can just do this again. This thing on port. Compile client. Oh damn. The warning. I think it should be this. This warning again. Is this allowed? Cool. Nice. Beautiful. 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 Okay, we're done with the question. Let's move on. Let's move on, boys. So we have done this. So next, let's try to do this then. Let's try to do this. Using pipes, you need 4.c files at a minimum, client.c, save pass.c, students.c. This is the student model. It's kind of hard to implement it right now because of the time constraint. So let's just skip it. Okay, let's do the make file afterwards. But then first, let's see all of these files right here. Let's just see it in a series. So this is the condition variable. So we have to remember that pthread condition variables is cond t cond. Yep. And to set the condition and stuff like that, you just do wait and broadcast. It's pretty important. So for the condition, so let's just notes.md. The point of this condition variable is you have to do condition wait, and after doing this, set the condition after notifying all the threads, broadcast, and it is done by cond t. So is that, so that's basically it. So this is the conditional variable. Let's go to main threads. Okay, thread IDs. Okay, mutex init and mutex. So mutex is this, cond is this. So mutex, well, you initialize it, mutex init and cond init 2. Pthread mutex initializer or pthread mutex init cond null. 1 second. ఏమైంది అమ్మ అలా గిస్తూనే ఉన్నావమ్మా. గెడే మేలేరా.
జడే ఇప్పు అందుకే అప్పుడు డిస్టర్బ్ మళ్ళీ పెట్టాలి కత్తిద్దు నేను చూసుకోకపోతే అలాగా నేను
ఇక్కడ అయిపోతున్నా.
ఆ మంచినీళ్ళు తాగత్తి గ్రీన్ క్యాప్సూల్ వేసుకున్నావా మీ చెల్లికి ఆ నూర అంతా పనిగట్టు అయిందంట అంతా తీసుకెళ్ళి వస్తాం డాక్టర్ దగ్గరికి వస్తాం తలుపు వేసుకోబెడ
అయ్యో డామ్ బ్రో. So again, I'm back. So, just seeing if this is working properly. Apparently it is working, so it's good. Okay. So again, I'm back. I'm sorry. Okay. Um, the conditional variable is basically it will wait for a condition to be true. So the worker will wait until the ready is a positive number, and the signaler will set the condition, and it will broadcast the condition on the conditional variable right here. And working is basically based on if it is not ready, then you have to wait. If it is not ready, you have to wait on the on and card and mutex. Let's just see. The wait condition here. Let's just see the man page for this. Wait on a conditional variable basically. Atomically blocks the current thread waiting specified by card and release the mutex specified by mutex. Yeah. Signal or broadcast with the same conditional variable and the current thread acquires the lock on the mutex. Requires the lock on mutex, right? And then do work. I have a little doubt though. A little question here. That is okay. Unlock is also okay. And then sleep, you're doing just sleep for a while to some network. Then log in the mutex and then set in the condition, and then you're broadcasting the condition that the condition has changed. And then you're doing signaling, all the tests are working. Unlock the mutex and then return none. The point is, how is this? Why is that? Like, isn't this? And I have a question to ChatGPT. Or you can just use black box, I think. Function takes a void pointer argument which is cast to in pointer and dereference to get the thread ID. Oh, right, because it is a pointer to an array, so it is dereferenced again. Okay, nice. Okay, nice. Cast to in pointer and then dereferenced again. That's pretty cool. Nice. So that is that. Basically, wait, broadcast, and it wait, broadcast, init, this thing. That's the basic thing. pthread conn wait, pthread conn broadcast, pthread conn init first, and pthread conn t conn. Oh, it's 2.c. Well, if you just alright, cool, it's okay. There's nothing here. Let's see the demonizing thing. Demonize a TCP echo client server. Okay, this must be interesting. So what is this? Is the client, which is time message. You are, what is this? Uh, time message has this void. Int bool, okay, bool operation. File message buffer size, int message length. Client IP is 32 unsigned integer, which means that it is only positive, right? Yep. Unsigned integer is only the integers which are positive. Yep. Okay, cool. And time message. And if okay, you're defining the struct as time message. Okay. You're putting it here. And then what is happening here? The standard things. ConfD standard things, the request and response. Okay. Set standard connect standard connector is ever standard, and then you're doing request dot client IP is inet add arg1 operation is true. Request dot client IP, I think it's just it's actually server address, but okay. Operation is true, message length is 0, then you are writing it from the request structure. You're writing the request structure to the ConfD, then you're reading the response. Okay. What did the server.c say? This may not be actually this may not be, a demonizing, but it's just for time, asking the time, right? Time dot ht bool time message dot okay. Because this is new. But let's see the main. Standard. You're defining the signal here. Signal handlers, sig action SA. You're doing SA handlers. You're defining the function, and you're emptying the SA.SA mask, which means that no signals can block the signal handler. SA.SA flags is SA restart. Okay. Sig action. You are setting sig child to and SA and null. What is null in sig action? What is the third argument in sig action, boy? What is the third argument in sig action? Third argument is the action is or restrict old set basically. If you are willing to save it or not, you're basically not saving it. So basically, it will not save it and bind and listen and accept. Okay, 1 second. Okay, you're doing accept. Fork child process. You're reading from the request. Which you have defined it here. You're reading from the request, and then your request operation is true. Client IP is equal response to client IP is equal to request dot client IP, and response dot operation is false. Get current time. You're putting into response dot message puff size. So response get current time. Let's see get current time. The function is doing chars buffer size to buffer size. Time tt is equal to time null struct tm. We're putting into local time. Time str is AC times. Time str is all of these things is the getting the current time. This is kind of hard, I think. Calling the time function and then you're calling the local time function onto the struct tm, and then you're calling the UC time function on the struct tm, and if you're getting time str is true, you're basically doing str and copy to the buffer from the time str until the buffer size -1, and then you are doing buffer size -1 as 0, and then you are doing str spn cspn if there's any uh, in new line character, you're just putting in null termination. I do not know why, but yeah. Else s and printf buffer size failed to get time. Okay, very interesting. All these functions is just important. And then you're doing sick child handler. Where is the sick child handler that you're actually doing? They're actually calling sick child handler or sick child handler, putting in there. What it does is takes in that and it waits till wait PID all of the. Okay, understood. Whenever the child terminates, you're waiting till all of the child terminates and you're putting a null and with no hang. What does this line indicate though? I do not know. But all in all, you're getting the get current time, you're getting the time, you're setting it there, message length, str length of that, and then you're writing it to response. The printf send correct time to this thing, and you're doing else again, which is operation unknown operation received, else if r is equal to 0, which is this client disconnected, else error reading from client, close confd exit 0, else if parent process just close confd, just do nothing and just close the confd, and then else PR fork failed, close confd, and then close less than ft, return 0. So the meat of the discussion here is this function, is both of these functions. So let me just see this. Black box is actually really convenient though. Although why is it, it's taking a lot of space. What do you It's just taking a lot of space. So let's just ask ChatGPT though. So the parent process wait for state changes and its child process. Does it going to wait for any child process? Means that we don't need information about child's exit status, just that it has terminated. Oh, okay. Will be return immediately if no child has exited. Oh, okay. If no child has exited, return immediately. Okay. So wait period is used for zombie processes occurs when a child exists but the parent does not wait for it. So you have to wait for it. Okay. and cool. And then while, put it in while and greater than 0. Zombie process occurs when a child process exists, but the parent does not wait for it, so the process still holds a net in the current returns the runtime as the number of seconds is the Unix. This thing program converts the T into structs that contains broken down time in local time zone. OSC time is basically struck into human readable string in the format. For example, this if time is tr, this checks if a successor provided produces a valid string, copies the time string to the buffer. Oh, okay. It leaves room for the null terminator. Null terminates the string case str did not do so. This removes that AC time. Okay, eventually the string str CSPN finds position in the first new nugget and able to get a clean string. Else, if AC time failed, example due to invalidity. Nice. So I'm just not really sold on this wait PID. So wait PID, what does it return? It returns a positive thing, positive integer, I guess. Um, okay, nice. W no hang flag is just used for to return immediately if no child is exited. And then while you get these things, will you get the PID though? Will you get the PID of the child process? On wait PID? Yes, you can get the specific wait period returns the PID itself. Yeah. Yeah. And there are no child process that have changed state. Okay. Nice. If there are no child process to wait for, wait period will return 0 or -1 indicating either no children or error which will exit the loop. Nice. No child process to wait for, wait period will return 0 or -1 indicating either no children or an error which will exit the loop. Okay, that's pretty cool. Ah, damn, bruh. That's pretty cool. I think this should be this. We need to kind of put it into our notes. So let me just do that. So we're just checking if while and we're not doing anything though. Just handling it like that basically. We're waiting and getting the PID if the child terminates. Hmm. And we're setting that thing on here. The sig action. For this process, sig action, sig child, and I say null. Exit failure or exit one. Sig child for handler. Sig empty set SA mask. Say dot SA flags. SA restart to restart. Okay. Interesting. And SA and null. Interesting. Yeah, the previous handling information for the signal is returned to the user, which is by the old act. Okay. Just want to. We can save the old act here basically. Sig action. What is the old act? So for the current signal action for the specified signal sigma. Yeah. If you want to restore the previous signal header, we need to inspect the previous access signal action to check whether the signal was previously ignored or had a custom handler. Yeah, okay. So again, please set no additional signal block during the handler. A suffix is 0 and then sig action. Sig child and new act and old act. Now you can handle the exits immediately. It's for child termination. Just to wait, okay. Same as SA flags and the SA handler. Now when I want to restore the old act, what to do? Restore the old act for signature. Okay, nice, nice, okay, nice. So this thing just waits for the children to terminate. To prevent these zombie handlers basically, and W no hang if the state has not changed non-blocking. -1 null, W no hang. That's pretty cool in it. So the get current time, pretty. This thing is like you need to save it. I'm gonna just save it in my folder. Okay, that's pretty cool. That's pretty cool in it. And so basically, T is equal to time of null, and then you call the local time on T, put it into struct TM, pointer to TM, and then you're putting into AC time, which is for reading in string basically. Put it there, and then just if for that, and then just str and cpy, which is copy to buffer, time is your buffer size minus 1, and then you're null terminating, and then if you're getting any backslash n, which was set by ASC time, you just do backslash 0, and else smprintf failed to get time. Okay, yeah, so smprintf to this string basically, buffer size failed to get time. That's pretty cool. That's nice, very nice. But we are not done the demonizing thing. And then you'll print the convert server into daemon by going through the steps discussed in the class. Convert a server into daemon using daemon, add a file in the exent directory called curtime with the characteristics shown in the example telnet file I have in my slides, but additionally include the line port as good access where access the port you have chosen for your server, and start net today and verify that the server is extended when we have not studied. You need to include two different server files for the two different types of demonized methods. Um, okay, let's see the daemon function, which is using the daemon function basically, converting the server code into the daemon, which basically starts at the boot time. What is it doing? Main struct and all of this stuff. It's okay. Bind listen, service started, accept, and then the child process you're handling it. Cool. Uh, cool. Response to client IP is the request that client IP. Response that operation is equal to false. Get current time. Response that message buff size. Buffs get current time. Should pass in the buff size also. Buffer size. Okay. Put it into buffer actually, so we put it into response that message, and the message will be of buff size. Okay, right, connectivity response, else. That's cool. So where are you using the daemon? Oh, yeah, using the daemon. Where are you using the daemon? Okay, server daemon, right? Okay, what are we doing right here? Okay, I think this is not the file that we're looking for. Is it daemon init? There's a lot of errors here. There's a lot of errors here. I don't know why, but daemon init.c. Okay, this is the daemon init. Um, start.h is used for the this thing, the file manipulation. I mean the file permission thing. I'll just be back. Let's take a pookie break. I'm just kidding. Let's take a pookie break. Listen to this audio. It's pretty funny. Okay. Bruh. What is this, bro? Okay. Okay. Enough of this. Let's just get back. Demon alert. PID, PID. PID is equal to fork. Exit 0. Set SID. Make the child processor session leader. Okay. By the way, I think it's high time I start lead coding, but I'll do it after. I'll do it after this Friday. So I'll do that on 17th. Most probably, I will do a lead code problem because that is also important. So make the child process session leader. So I think the main uh, processes are basically you fork, right, and then make the child process session leader. You can do double fork also, but after forking you have to create a session by using set SID, and then ignore signal, hang up signal, doing this, and then second fork. Yeah, second fork, change the working directory to this, and then you mask it 0, and close all inherited file descriptors. It is by sysconf sc open max. C open max is just a macro. Sysconf. You have to close all the inherited file descriptors. Damn. And then you have to call daemon init, and then while one sleep. So the login and handling sections, and placeholder for daemon tasks. Okay. I don't think daemon will come, but this is the process for daemons. So you make a fork, you make a set SID, you I'll just show you the slide. Give me a second. Give me a second, dog. Mm, the slides. Okay, I got the slides. So look, yo. So look, um, this is the process for daemons. Basically, daemon init. You do void and int. Let's see the man page for daemons though. Daemon init function. Let's see the man page for that. if it even exists. Oh, it exists daemon. Daemon function is there, but also daemon init function, it's not there because we are defining it. Oh, I'm so dumb. This is just manual daemoning, basically manually creating a daemon, which is basically do this, and then you fork exit 0 from the parent, and make the child process assassinator, which is set as id. If PID is not equal to 0, which means we are in the parent process and we are exiting from the parent process, so we are only left with the child process, and then set as id, and then ignore hang up signal by using this, and then double fork it again, and yeah, okay, and then chdr slash do this umass 0, close all unused file descriptors, and then return 0. So set as id signal. So the first thing will be PID, and then you fork it and exit the parent process, and then you do set as id, and then you do signal sig hang up to sig ignore, then second fork exit 0, parent process exits, and then change the working directory chdr slash, and then umass 0, and then close all the inherited file descriptors using int 0 I syscon f sc open max I plus plus close of I, and then return 0. While one placeholder for daemon task sleep, then return 0. sc open max, so it is sc underscore open underscore max syscon f. Oh, the also we on this question, I have to know why this did not work though. This thing. Let me just give it to ChatGPT, and let's see what it says. No, then why is it not? It gave me errors though. 1 second. Yeah, we're in Q1, right? Give me errors. Why did it give me errors, bruh? See, thing is, I want to do this. it says that the error is done. Can I do this though? Oh, at least one. Macro defined indicates one argument m, which is the format string. Why have I gotten this? Hashtag. So it should be hashtag damn. Okay, now that's cool. Hashtag. Nice. Let me just come back. Alright, I think that's the end of the 3 stream. 3 hours. We've sat for 3 hours. That's an achievement, and we will do longer streams after some time. But yeah, thank you for tuning in.